All right, let's take a look at another example here. I've already started it. You can see we have 2 sine squared x equals 1. Just divide both sides by 2. And remember that sine squared of x really means the quantity of sine x squared equals 1/2. And so the next step then is to take the square root of both sides. Now, when we take the square root of both sides, we're going to get the plus or minus square root of 1/2, which is really plus or minus. You can square root the top and the bottom. It's going to give you 1 over the square root of 2. Now, this plus or minus is important because if I take a negative and I square it, I'm going to get a positive. And so that's why we have that going on there with the positive or negative. It's also going to give us 4 solutions from 0 to 2 pi instead of just 2. Because I really am, from here, kind of splitting this into 2 problems. I need to find when is sine x equal to 1 over the square root of 2, and when is sine of x equal to negative 1 over the square root of 2. You can use your calculator here. If you use your calculator, it might be easier to stay in degrees and then change it to radians, or if you type it in radians, so like, actually, here, I'm distracting myself. Let's just go and look at this one and this one on a circle, because I think it's easier on a circle. Okay, hopefully you're seeing 1 and square root of 2. Hopefully you're remembering, hey, 45, 45, 90 triangle is 1, 1 square root of 2. And since I have sine is just y over r, I need to find where y is 1 and r is the square root of 2, or where y is negative 1. Well, that ends up giving us 4 different triangles, right? Right here I've got 1 over the square root of 2. Here I've got 1 over the square root of 2. Down here I get negative 1 over the square root of 2. I did this one backwards, I'm sorry. And down here I have negative 1 over the square root of 2. So these are 45-degree angles. Hopefully you remember that's pi over 4. This is going to be 3 pi over 4. This is going to be 5 pi over 4. And this is going to be 7 pi over 4. So your answers are going to be pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. On the calculator, this one's just a lot more challenging, but if that's what you're doing, you're just going to have to type in so I'll show my work here. So if you're doing it on the calculator, you'll need to do x equals the inverse sine of 1 over the square root of 2. And that will give you, I think, 0.785 something. And that's in radians. So if you're in degrees, it'll just tell you 45 degrees, and then you can just change it. That's fine. Another option is to take this number and divide by pi. Okay. If you divide that number by pi, it's going to give you 1/4. Okay. And so that gives you this angle. You still have to think it through and realize there's another answer over here. Then in your calculator, you're also going to have to put the inverse sine of negative 1 over the square root of 2. It'll give you negative 0.785. You have to realize, okay, I have to go around the positive direction, get that angle, and then also realize that there's a 4th answer here. So, like I said, if you know your 45, 45, 90 triangles, it's a lot easier just to think it through that way, but you can get it with a calculator too. Let's take a look at number 7. In number 7, you'll find that you have to rely on the calculator here, okay? Equation's a little more complicated, but we still want to isolate or get the cosine by itself. So I'm going to start by subtracting 1. That gives us 1/2 cosine of phi. That's how you say this, phi. 0.2108. And then to get rid of the 1/2, we can divide by 1/2 or multiply both sides by 2. So cosine of phi is going to be 0.4216. And again, probably most of us do not know that off the top of our head. It's not a special right triangle. I do have that written down here on my paper. Because to find phi, then we're going to have to take the inverse cosine of both sides. Now, if you want to get an answer in degrees, you're going to have to be in degree mode. So go ahead and change it to degrees. And when you do that, you get 65 degrees. And so what that means is on your circle, if I have a 65-degree angle, the the x value here over r is going to give me 0.4216. Okay? And so if r is 1, then x is 0.4216. Doesn't matter too much. You just have to think about where is the other solution. Okay, so we're working with cosine. So where else is cosine positive? Well, the x values are also positive down here. And so you know this reference angle has to be 65 degrees. So to find that angle, we've got to take 360 minus 65. And that's going to give us 295-degree angle. And so between 0 and 360, these are my two solutions. Just a little side note, all solutions, how would that change things? If we need to give all solutions, we just put 65 plus 360k, where k is an element of the integers, and 295 plus 360k. You don't have to rewrite k as an element of the integers because you've already said what k is up here. And so this would be for all solutions. This is for just 0 to 360. So, quick summary, the strategy is similar no matter the problem. You're going to get the trig function by itself. Here we ended up with 2 answers. And then from there, we find one solution, and then we have to think through the circle and find either one other, or in this case, there were 4 solutions. And that's the conclusion for question 7.